Hello students, hope you all will be good. Today we are going to discuss a very important topic in physics, momentum. From 2023, this topic is a part of O-level physics 5054 as well. Initially, this topic is already the part of IGCSE physics, which is 0625. And it is in a very detail, this topic is discussed in A-level physics AS, especially code 9702 as well. So if you are taking any of these courses, this topic is for you, right? We start this topic from introduction because students who are right now preparing for O-level, this topic is new for them. And similarly, who are going in AS exams or A-level first year exam 9702, this topic is quite new topic for them as well. So let's start the topic. Momentum. The definition is momentum is basically quantity of motion due to mass and velocity. So basically it is the product of mass and velocity. Right? It is the product of mass and velocity of a body. We represent momentum by P and it is equal to mass times velocity. Okay, it is a vector quantity. Since velocity is a vector, mass is a scalar. Whenever we multiply a vector quantity with a scalar quantity, answer is always vector. Okay, right now also from the formula P is equal to mv, we can see the SI unit of momentum should be the unit of mass is kilogram. Velocity is meter per second, so its unit becomes kg meter per second. Another famous unit of momentum is Newton second, right? We can obtain Newton second as if we do a little bit calculation of it. You know, Newton is a unit of force, and as SI base units, we know that force is basically kg meter per second square, because we know that F is equal to ma, mass times acceleration. Mass is kg, acceleration is meter per second square. So the unit of force, which is Newton, basically comes out as kg meter per second square. Times second means multiplied by second. Now since there is power of the power of s is 1 only, so as a result it becomes kg meter and s power minus 1. So this unit is same as the basic unit of momentum. So that's why we can say that the unit of momentum is kg meter per second or Newton second as well. There is another significance of this unit, Newton second, which we will discuss later. Okay, so let's come to its definition again. It is quantity of motion, which means basically quantity of motion is that thing which depends upon the mass as well as the velocity of object. For example, if we have a car, suppose this is a car and here we have a, let's say, a bigger object, let's say a truck, right? Both are moving with the same velocity. Let's say velocities of them are equal. So imagine both of them hit a wall or something in front of them. So what will happen? Definitely this truck, as it has more mass, let's represent it by capital M and small, the mass of car by small m. Definitely the truck will cause a greater damage, although they have same velocity, but it will have higher momentum. Higher momentum means its quality of motion will be high. That's why its impact will be high because of its mass. So basically that's why we can say that momentum is something which depends upon the mass as well as the velocity of object. Okay, right. If I have to do an example, let's say a car of mass 1000 kg possesses a momentum of let's say 12,000 Newton second. What will be its velocity? So definitely, as we know that momentum is the product of mass and velocity, since we have to find out velocity, so that it will be momentum divided by mass. So by dividing these values, we get 12,000 over 1000. Simply it is 12 meter per second, the velocity of car. Okay. So this was a concept of momentum, a brief definition and the formula here. Okay. Now let's move to the next thing, which is change in momentum. Basically, we discuss change in momentum whenever there is like we can say a ball of mass m moving towards a wall. Let's say here is a wall. This ball of mass m is moving towards this wall and it collides with this wall. So then definitely the ball will rebound and there will be a change in its momentum, right? So we have seen that this change has occurred within a very short duration of time, because time is very small in this case. The time is only what the ball takes when it is in contact with the ball. So that's why this time is very small. Similarly, if a cricketer hits a ball with bat, so in this case as well, the ball will have momentum and the bat as well. So when they will collide within a very short span of time, means in you can say milliseconds of time or hundredth part of second, there will be a change in momentum, right? So basically we are talking about this change in momentum. So since this happens in a very short interval of time, so that's why this is also called impulse, right? Impulse is the change in momentum. For example, let's consider that a ball is moving, a ball of mass m is moving with its initial velocity, let's say it is u, and someone applies a force on the same ball and now its mass remains same definitely, but its velocity becomes v. So definitely its initial momentum is mu, its final momentum will be equal to mv. So change in momentum will definitely be final momentum minus initial momentum, means mv minus mu, right? So this is the formula for impulse as well. Keep in mind that impulse is basically that change in momentum which occurs in a very short span of time, right? Now let's move to another very important topic, which is momentum and force. It can also be regarded as momentum and Newton's second law. Since Newton's second law is basically that law which defines the force. So that's why this topic relates momentum with the second law of motion. Very important topic. So let's say, let's continue this same example in which change in momentum is mv minus mu. So we have seen that initial momentum of a ball is mu, final momentum, it is mv. So change in momentum is equal to mv minus mu definitely. So this is change in momentum. If we talk about rate of change in momentum or rate of change of momentum, then we have to consider that short span of time during which this change has occurred. So rate of change of momentum will become mv minus mu divided by time. Right? Now if we take m as common from here, we get v minus u over t. And v minus u over t, it's a very famous formula for acceleration. So we know that this is acceleration, so we get ma. And every physics student knows that ma is basically F, or net force. So from this working, we come to a conclusion that rate of change of momentum is basically equal to net force. This is the relationship between momentum and Newton's second law, that rate of change of momentum is equal to the net force. So what is this net force? This net force is basically that force which is applied by one body to another during the collision, right? So this net force basically, net force is that force, in this case, which one body applies on another during collision. Definitely when bodies collide, both bodies exert force on one another, and we know that those forces are equal and opposite following Newton's third law of motion. Right. Let's do some examples related to this. One example, if they say that a football of mass 2.5 kg is moving with a velocity of, let's say, 10 meters per second. It is hit by a force in the same direction and its velocity becomes, let's say, 12 meters per second. Find applied force if it acts for, let's say, 0.02 second, because the force which hits the ball, definitely it applies for a very short time. Okay, now if we have to solve this example, we can see that final momentum of the ball will be mass times final velocity, which will be 2.5 times 12. Definitely it should be 30 Newton second. Initial momentum will be 2.5 times 10, that will be 25 Newton second. So by following the relationship that net force is equal to change in momentum divided by time, or mv minus mu over time. So by using the values, we have 30 minus 25 over 0.02, which is 5 over 0.02, or 500 divided by 2. If we remove decimal point, there will be 100 in the numerator, and this comes to 50 Newton. So that's the applied force in this case. Okay. You should notice one thing in this example, that it is said that force is in the same direction. Since we know that momentum is a vector quantity, so direction matters. Now, in another case, let's say if bodies reverse direction after collision. Let's suppose the same ball, although yes, it moves with the velocity of 12 meters per second, but in opposite direction, right? Means in above example, if ball moves in opposite direction, definitely when it is hit in opposite direction, that in that case this situation can happen. If ball moves in opposite direction, what then? So as we know that velocity is also a vector quantity, so definitely in this relationship, if we take one velocity as positive, other one will be taken as negative. So let's take this u as negative and v as positive. We can take v as negative and u as positive as well. We are not, even if net force the answer comes in negative value, still that doesn't matter, because we have to focus on its magnitude only, not the negative sign. So in this case, net force basically will become mv minus m times minus u over t, because one velocity, because of reversal direction, the other velocity is taken as negative, so it will become mv plus mu over t. So that will become 30 plus 25 over 0.02, means 55 over let's say multiply by 100 as well over 2. So by cancellation it will become 55 times 50, and that will become 2750 Newton. That's the force, and we can see from here that this force was very small as compared to this one is much larger force, because the force is applied opposite to the direction of motion. So that's why a larger force is needed in this case. So from this relation, as you can see that force is equal to change in momentum over time. We can talk about their units as well. Since force is Newton, change in momentum means simply it is momentum over time is second. So if this second should be multiplied here, so we get Newton second as the unit of momentum. So this is another logic behind the unit of momentum as Newton second. So a second logic is this one also. You can take, and you can, for your concept, you can understand, you should have an understanding of both of them, right? So this video is ended till here. In the next video we will talk about law of conservation of momentum, a very important topic. Law of conservation of momentum, and we will discuss its application. Along with it we will discuss collisions. Collision is basically part of A-level syllabus. There are two types of collision, elastic and inelastic. So in the next video we will discuss these terms as well. So I hope you understood the basic points. If you have any queries, you can contact me. Please subscribe to this channel. Thank you.